Hello everyone, my name is Peter Okello. I'm a geospatial engineer at the Kenya Space Agency, and today I'll take you through a presentation on how we can leverage on open source data and tools in developing geospatial solutions. Well, my case study will cover the platform Google Earth Engine and how we can use Earth observation data in some of the application areas and produce products using Google Earth Engine. The first application area is agriculture and vegetation. And in agriculture and vegetation, using open source data and the tools, that is Google Earth Engine, you can be able to do land cover and land use monitoring, whereby you considering the IPCC classes, you can be able to determine the type of land cover that is in a specific region or place. Again, you can do arable land monitoring, and then you can also do crop yield estimation. Crop yield estimation, you can use the generated statistics, that is the land coverage, the land areas for specific land cover type. Let's say if it's a crop like maize, so you determine the land coverage for that crop, and using that you can be able to estimate the amount of crop yield output for that specific crop. The last one is on crop health monitoring, and this is basically using some of the indices like NDVI. You can be able to monitor the health of a crop. The product that you are seeing is on vegetation cover for our country, Kenya, and we used Earth observation data, that is Landsat 8, and the study period was from 2013 to 2020. And again, we used Google Earth Engine to produce the product. And as you can see, it's an animated GIF, and from what is playing, you can deduce that the year 2017 had the least vegetation cover, whereas in 2020 there was the most vegetation cover. The next application area is on forest resource management, and under forest resource management, you can be able to use Earth observation data and tools to monitor forest and their extents. You can as well monitor and support the conservation of biodiversity. Under this application area, as Kenya Space Agency, we have done a lot of studies, and some of the forests that we have done studies on include Aberdares Forest, Kibiku Forest, Ololua Forest, Ngong Forest, and in Kibiku Forest, the product that you're seeing, we use Sentinel data, and Sentinel data has an image resolution of 10 meters. And for this study, we considered 2016 and 2020. And the findings were within those study periods, the forest cover in Kibiku Forest had increased by 12%. The third application area is in urban planning and infrastructure, in which in urban planning, you can be able to use Earth observation data and tools to do urban delineation, whereby using the satellite imageries, you can be able to define the extent of an urban area. Secondly, you can be able to monitor the growth of an urban area using Earth observation data and do analysis depending on the study periods that you have chosen. Some of the observation data, let's say Landsat, goes all the way up to the 70s. And with that, you can be able to do a monitoring of how an urban area has grown over time. The next application is on land use planning. And this is where now you get the spatial component of a feature, and using that you can use it to plan and organize uh, the setup of an urban area. The next one is on environmental impact, and these generally look into the green spaces and wetlands that an urban area has. And for the product that we have, uh, that is Nakuru Municipality Land Cover Map, the wetland that is Nakuru Lake, you can see, and a lot of studies have been done that shows that the lake has been expanding over time. So using Earth observation data, you can be able to do and monitor how the lake has been expanding and swelling over time, and deduce or generate information on the coverage. The last in urban planning and infrastructure is using Earth observation data, you can be able to do routable road maps. This will inform the general public and the road users on the passable and the passable roads and the roads that are in good condition and one can have access to these roads very easily. So for the product that you see, that is in Nakuru Municipality, we used Landsat dataset of 30-meter spatial resolution. And the study was done from 1989 to the year 2020, just to see how urban Nakuru Municipality urban area has been growing. Again, using Google Earth Engine, you can be able to produce a user interface, and the user interface give you an easy access and integration of the products that you have produced to have access and do analysis and obtain information directly from the platform without necessarily engaging or maybe writing the codes. So I'll just play the short clip and see how the user interface works. And as you can see, it's divided into two map areas, and there is a short description of the products that we have, that is the IPCC classes and urban. Then these are the number of years that the study look into. And this is for map 2. Again, it has the study years that the project was looking into. And then there is a legend and the graph here, the bar graph showing the generated statistics. Again, there is a slide feature, and the slide feature is just to compare two different products for 2 different years. So this is the Landsat for 2010, the Landsat imagery for 2010, and that is the classified map for 2010. And the classification, the classes that were considered are the same. Again, this is the Landsat image for 2020, and this is Landsat 8, and the classes, the classification map is overlaying on top of it with the classes. So this is just a tool that you can use to compare 2 different years, study years, and generate information on how an area has been changing over time, and finally inform the general public or maybe decision makers on what has been happening And that is the end of my presentation. Thank you.